Hi, my name is Warren Matthews. I'm pleased to introduce our next free paper presenter, Joel Flatt. Joel is a prosthetic technician at Hamilton Health Sciences, and today we will be presenting on a hockey terminal device.
All right, hello again.
Give the presentation.
I guess I had a good lunch. This works this time. Okay, this is our this is hockey terminal device project. Worked on it for a number of years, and so we want to come to the OPC and share what we made. Hopefully you'll find it interesting and encouraging when there's a need that somebody has that you can't quite find the right parts from off-the-shelf options. So we made a custom terminal device. It was made to help a young athlete compete at the junior hockey level. So junior hockey, if you're not familiar, is the age range from around 16 to 20. Average age is 18 to 19. And it's a fairly competitive level, but then you've played a fair amount of hockey. So it's it's more than just your average youth league. And so our initial challenge was we were using the currently available terminal device that was on the market. We were using the TRS PowerPlay, which you'll see in a bit. But a few years ago, it's around when he turned 17, he was filling out and getting a lot stronger, and he was just wearing out the terminal device very quickly. So we needed to develop a terminal device that would allow him to keep playing hockey and pursuing his dream without having to replace his terminal device all the time. And for reference, this terminal device is for the top hand of a hockey stick, so you'll see this in a minute. And before we get too further along, just in case there's anyone who's unfamiliar with hockey sticks, traditionally they were made out of wood, so the PowerPlay device, which you'll see in a little while, goes over top of the stick, which is perfect for that. But now it's almost difficult to find a wood stick, so almost all sticks are made of carbon fiber, resin, composite materials, and they're all hollow. So we're going to be utilizing the hollow end of the top of the stick. So this is our patient. His name's Josh. So his goal was to play at a very highly competitive junior hockey, and he eventually wanted to apply for a college scholarship in the United States. He played hockey in the Hamilton area, as well as playing in the United States Premier Hockey League and the Greater Ontario Junior Hockey League. With that level of competition, he needed a robust device. And so you can see here as he's playing, if just at first glance, you wouldn't really notice that he's a transradial amputee. So some history, he was born with congenital transverse deficiency of his radius and ulna due to amniotic band syndrome. He's been a patient at Hamilton Health Sciences for most of his childhood. Hockey's a big sport in his family. His parents and siblings, as well as a few other sports. And like I mentioned, he used the TRS PowerPlay terminal device, and he had that was mainly what he used, and he had a lot of success until he outgrew it, basically. And then I'm just going to show you just the device history. My top years are completely incorrect, but the socket that he initially used was just a standard lamination fiberglass, nightglass. He was using upper extremity locking liners from Oser, the 721 lock, and he was using an aluminum WD flower quick disconnect wrist, and we've commented on the terminal device. Around 2017, like kind of winter 2018, he needed a new device, so his old device had gotten beaten up a lot from playing hockey, so we switched material to more of a carbon Airlon fiberglass mix, and we moved to the 621 Oser lock and Sportliner, so that's the lower extremity lock. We needed it to be a bit more durable. We also switched to the titanium FM quick disconnect wrist, also from Flower. We found the aluminum wrist was just, the material was wearing out quite quickly, and the titanium solved that problem. And then that's when we began repairing the off-the-shelf device as often as we needed to. And then currently the socket, suspension, and wrist are all the same. That's been a success, and we've tested and developed our own hockey terminal device. So just want to get into the initial issues with the off-the-shelf device. So you can see here, this is the urethane that connects the wrist to the power play, the part that goes over top of the stick, is cut. So this would happen quite regularly, and TRS would replace it, but it was, he was having to have 2 or 3 of them at a time, and when you get a tournament, it would get fairly stressful when they would be broken. This is the power play, so the stick goes into this device where the blue arrow is showing. And then on the other end where the threaded rod is, that would thread into the wrist. So we worked with TRS to try and fix the durability issues we were having. TRS had a nice idea to remove the urethane and connect a flexible hose in between, but as you can see, I had to do some technical wizardry here to try and keep it together. So we ended up, the threaded rod pulled apart, and so we ended up bolting it together with 632 nuts and bolts. And yeah, we just had to keep getting more and more creative with repairs for a while. Once we realized we needed to make our own device, we had to discuss this quite a bit. How are we going to do this? So initially we decided what we were going to do. We wanted to build off of the flexible hose idea, and we also wanted to make our own stick attachment part. So we decided to make basically a 2-part attachment. So there'd be a stick portion and a flexible hose portion that would attach to the wrist. Some of the benefits of this was, in our view, was that if the hose portion were to break, you would be able to do a quick swap of the hose section, and then you could continue playing. So that could be done on the bench during a game, as well as if the stick broke, we would be able to still use the hose portion and remove the attachment that went into the stick. And I'll show that next here. We also, just as a side note, set it up so that the push button for the quick disconnect was easily protected, but also available in case he did break his stick during a game, because you're not allowed to carry your stick back to the bench, so it was easy to let go of the stick if need be. Okay, so the stick portion, I brought samples of this project with me, so if anyone wants to check it out later on, you'd be more than welcome to. I've also got a nice mini stick, so I could fit it in my suitcase. So the stick portion, I'll just grab it here. So this is the one of the versions we made, the current version. So this would go into the hockey stick. So as you can see, the blue section, which is here, is going to slide into the end of the stick. And once you do that, there's a, actually I'll get to that next here. Yeah, so this would be pushed into the end of the stick. I'll grab that. Okay, so then this is actually an interesting fact is the stick tapers down, so this doesn't quite fit too well. You have to kind of push it. But in the actual end of the hockey stick, it fits fairly easily. It goes into the stick fairly easily, and the inside diameters of the sticks are all quite a bit different. So it was a bit of a fine tuning of having this piece machined to fit. So basically what's going to happen is this is going to just insert into the stick like that, and then as you can see, the blue arrow is pointing to like a rubber gasket, and then the second arrow is pointing to a bolt that I'm going to tighten up, and then as that bolt tightens, it's going to compress the rubber spring or rubber plug, and then that's going to be our force fit inside of this stick. So when I did a bit of testing to see how much force you'd have to put on, it was only about 5 Newton meters of force that kept the plug from slipping out. So this piece was made by our, we have a biomedical engineering department at Hamilton Health Sciences, and our one of our colleagues there, George Boyce, is a machinist. He made this. He did just a great job, and there was so much back and forth and remaking pieces, and I'm just showing what worked, not the parts that didn't work. There's lots of ideas before we got here. And so then there's a small set screw here, as you can see on the screen where the blue arrow is pointing to, and then just a caption of the hose portion. So initially we just had it rotate in, and that was how we left it. That would give us rotation at both ends of the flexible hose. And Josh was finding that was too much too much rotation. So he was needing rotation with his hand on the top to be able to do this type of when he's playing, but he was getting rotation from here or both. And then eventually one end would possibly just thread right out. So we put an undercut in the threads and inserted a set screw. The undercut is just so that we don't, when we tighten up the set screw, we're not wrecking the threads, because this is meant to be taken in and out multiple times during a game or just as from stick to stick. This proved to be really, really crucial for Josh's playing ability to have the control of where the rotation was coming from. And so now we'll get to the hose section, the flexible hose part. So the hose is made up of hydraulic hose, threaded rod on either end, a flexible center, and center insert, and metal crimps on either side. So this section needed to be flexible, but robust, and able to withstand a high level of competition. So initially we were with both the TRS repairs and the ones I made. A lot of the time we had a hard time keeping the threaded rod crimped into the hose. So the first versions, you can just see a few pictures here. George made me some custom metal bands, and I would take them and get them crimped. And I also experimented with the filler. So initially I used 25-second epoxy, which you can see in the one picture it just broke. So this would be a bit of a common experience at the beginning, where the threaded rods would pull out and nothing was staying. I tried gluing them, epoxying them. So what we realized was we needed a better end fittings. So as you can see in this picture, we were using the same hydraulic hose, and we moved to urethane for our insert, our flexible insert. So the insert would basically be the bottom part of the picture here, the piece in between the two threaded rods. And we settled on Parker hydraulic hose, 4,000 PSI triple braided it was called. So that refers to the braid inside of the hose, which will be, you can see a picture of that clear later. So hydraulic hose has got a rubber coating on the outside, which is great for hockey because it's going to get wet and it's no problem. The inside also has a rubber inside that once crimped, the threaded rod on the inside would be attached to. This particular one worked really well, except for you can see that the crimps actually take up 2/3 of the length of the hose, and I only had 1/3 of the hose that was actually able to flex. So this was pretty cool, but it was extremely stiff, and you can see when I get the sample going, this is the version that works. This didn't move at all, so it was just too stiff, but we were heading in the right direction. So this is where we found some success. So I'm going to show you the fitting that I use, so I'll grab that. Okay, so these are the fittings. So this is not, this was for a smaller pediatric version I was working on, but you'll get the idea. This is what the fittings looked like when they first came, and then, or similar to, and this would be after I've taken it apart. So I would cut with a hacksaw about here, and then you can remove this part, and then there's an inside piece that would go on the inside of the hydraulic hose, so then I would hammer that out, and I would be left with something similar to this. And you can see, I'll pass this around, the fitting has teeth on the inside, so as it's crimped in a big machine, it's going to bite into the hydraulic hose. So at this point, this was initially, you can see there's no undercut on the thread, so this was just before we did the undercut. So once we were having some success, we wanted to cut it apart and just have a look and see how things were going. So you can see here how deep those teeth bite into the hydraulic hose after it's crimped. And you can see there's a thin piece of steel, right here. That's actually a washer from like a light fixture that I found when I was doing some work at home, and it just came to me that this would be helpful for this job. So, you know, like most good ideas happen when you're not expecting it. But I put that on because I was so concerned the threaded rods were going to be pulling out of the hose during play. We actually only ever had them come loose once, and I think the nut really helped. So it was just light threaded enough that it wouldn't just explode. And then a little bit to the side, you can see where I pulled the protective rubber off of the hose. You can see the braided metal. So that's what gave the hose its stiffness. So once we were kind of heading in the right direction, we were pretty happy with how everything was going. We ran into some manufacturing problems. Just before I get to that. I'll just get this set up and then I'll send it around. And you can take it apart if you'd like, or just look at it. This will thread into here. So it's quite quick of a change. So if you're on the bench during a hockey game, you can quickly move everything around and have your next stick ready to go. And then this just hand tightens, doesn't need a lot of force. And then clicks in. I took the spring out of the insert as well because we didn't need any extra help pulling it apart. And then it's ready to go. You can move it around. And you can see it gets a bit of rotation from here. that around as well. So to just kind of continue, we ran into problems with manufacturing. So I was making this all in-house. Lots of help from some technicians with cutting the fitting ends and cutting the hydraulic hose. Cutting the hydraulic hose is very difficult to do. It's because of the rubber. You're burning the rubber off basically, so the entire machine room smells, and there's sparks everywhere as you cut through the braid, and it's a challenge. If you've ever seen hydraulic hose, it comes in big spools, so it's almost impossible to try and straighten it out and cut it, and it always wants to kind of go back to its natural arc. And the main problem we ended up having was crimping problem. So crimping is the machine that's used that kind of in a circular motion crushes hydraulic fittings. So these are hydraulic fittings. And basically I was trying to find, let's say, a 5.5 inch length. But when I started, I'd have to start with, say, 5 inches length, and then I would hope that as the crimp happens, it would elongate it by 1/4 inch on each end, because each end has a crimp. But as you can see in the picture, we would have some that would come out, they would have a longer, they would get crimped in excess of 1/4 inch. And then you'd have some hoses where a little bit, you'd get 5 3/4 inch, sometimes 6, like, it was starting to get all over the place. It sort of depended on how the crimping went, and probably a bit of a comment on how the quality of crimps we were using. The other issue we ran into was something called galling from my machining new contacts that I made. So because we had solved our problem with the rotation and only having it rotate from one end of the hydraulic hose, it was causing a lot of problems with the threads. So what I was told was that with the gauge of steel, stainless steel I was using and the Flower had, they were basically, with friction, the metal would sort of just wear off quite quickly or build up on the insert. So we had success, but we had some challenges to work through. So that's when a friend of mine works at a company called Battlefield International. They make custom hydraulic hose fittings for unmanned aircraft and other Formula One cars and some other high-end equipment. And so I was just talking to him about it one day and asked if they'd be able to, I was initially just looking for some advice, and they were really awesome. They helped us out a lot. So we started to communicate, and I sent them my drawings. They took them and did their CAD system to it, and they actually ended up custom making fittings that had the the threaded rod attached to it. And then they again did us a massive favor by sending these. They made the fittings and cut the hydraulic hose for us, and then they sent it to like a company that they work closely with in London, Ontario, called Safran, who works, they only do aviation, and so their machining and crimping is unbelievable. So this is a few pictures of the one I had from them. I don't have that one. Josh is using that one. They made up a number of them for us. It was just amazing how crisp the material was, and the lengths, everything came the right length, and it was a huge victory for us. There you can see just some of the drawings I had in the background of that one photo, but you can see how pristine their machining was. The lengths are all, everything's good. Even in the picture where the insert is threaded on, like it's perfectly level. Sometimes when I was getting them crimped, like the thread would maybe slide a little bit, so I'd be cutting it off afterwards. And so far we haven't had any of the galling issues either. So this is the final product. I mean, you can see it there as well. You can see it sort of broken down too. And I've got a short video here to show of Josh on the ice.
I've always had the dream, like, even with one hand, I wanted to go to the National Hockey League. Like, that's been my dream. I want to go to the NHL. I want to be the first amputee in the NHL. And that still is my dream. That still is my goal. So I was born that way. It was amniotic banding. I lost my hand when I came out of the womb. And I've been 5-finger, one hand since birth. So initially it did hold me back when I was younger, up until about the age of 5. I come from a hockey family. My dad played hockey. And it was pretty tough for me to watch like my brother go on the ice, and I was like, oh well, like how can I do that? Like, I want to go on the ice. Like, how can I do that? And initially, I actually said, like, I want to be a referee. Since I can't hold a hockey stick, Dad'll be a referee in the NHL. I was cut from the same team 4 times in a row. Last cut because of the same thing. Like, the coach didn't want to deal with having a player with one hand. So that was tough growing up. It's like, it's emotional, but it just gives me more drive. And look where I am today. I now play junior hockey in the United States of America. That's super important to me. It's my family. It's kind of in my DNA.
A video the hospital put together. It was just a short chunk of it, but you can still see the full video on YouTube. So conclusion, you know, just because something off the shelf isn't going to work, you can put a lot of effort in and you can make something else work. We're able to help Josh continue playing, which was really important for us. I really enjoyed collaborating with other professionals and other industries, hydraulic hose machinists, and learned a lot about hydraulic hoses that I never knew there was so much to know. And I also learned I didn't get into any of the things that didn't work, but there was lots of ideas that really did not work out. And it was like, you know, I don't know if we can do this, but just continuing on would be my encouragement to you. If something's not working out, just, you know, take a break, try again. Massive thanks to Karen. Again, she was the prosthetist who's worked with Josh for a long time. She's really done a lot of stuff to help him out, and she was great to work with. George, the machinist, he's amazing. He can make anything work. You can draw him something on a napkin and you'll have it the next morning. It's amazing. Mike, Fatty, and Wilmer for taking this to the next level. Lots of help from my coworkers. And special thanks to Josh for allowing me to share this project with you guys. We have a few, there's a few things that didn't work out. Thank you.
Questions?
Yeah. Is that flexible section with the hydraulic hose, is that a component I can have made or bought? Because I have an application for that.
Yeah, I could probably talk to you about it later. We hadn't really thought about that too much yet.
I basically did exactly what you did, but nothing worked, but it worked, but it didn't work.
Right. Yeah, we can just probably figure it out after. Yeah.
Was for the player,
Yeah.
or the patient, like, was the flexibility, like, needed to be really dialed in for him, or he was pretty easy going with that?
No, he was pretty complicated with that.
Yeah.
It was like, you know, we'd make them 5.5 inches long, and then it would be like you know, it's just like a little too long. So we shoot for 5 1/4, and then I think you'd get new sticks, and then you know, they'd all feel different. We'd have to go back to 5 1/2.
It's just the length that changed the flexibility of it?
Mostly, yeah.
Yeah.
The other thing that changed it slightly was how much he would cut his stick off, because if the more you cut off the stick, the stiffer the flex goes, so that also played into it. So we were kind of battling too.
And is it losing stiffness over time, or like is it becoming more flexible as he uses it, or is it doing?
Yeah, they do get more flexible as he uses it, and eventually they would just get pretty flexible. But the main problem we were having was the threads were wearing out first. That was the main wearing out part. Yeah.
Did you consider using any kind of bearing to achieve the rotation instead of it just rotating around the threads?
No, we didn't think about that. It's a good idea. It'd probably be worth exploring. But I think once we kind of got to this point, we felt like, you know, we had got something solved. So I think we left it at that. But that was a really great idea. Yeah.
What do you think about using a stainless steel braided hose like they do for cars? You know that you know how they have that silver braided hose that they use for some high-end cars?
Okay. Yeah.
Would that lighten it and make it easier for you than using that hydraulic hose?
Yeah, possibly. I didn't really consider that. We mostly kept our focus on the hydraulic hose for availability.
Oh, I was thinking a quick disconnect, you know, like they have for air hoses.
Yeah.
You just pull up the collar and it comes off. I don't know if it would snap, but
Yeah.
something easy, right?
Yeah. Yeah, that's a good idea.
And to cut the hydraulic hose, I was thinking to use a zip disc. You know what they do for, you get your grinder, and if you want to cut a nail or something, you have the zip disc, so you don't have to worry about a hacksaw. You just get the zip disc and it's gone in a second. Right?
Yeah, we did try that. It didn't quite work. We ended up using a chop saw to cut it with a specific blade.
Those steel things are hard.
Yeah, and they usually kind of splay after as well. Yeah.
Do you have any idea, in the end, the cost difference between the TRS and your custom?
Yeah, it's all costed out for funding and that. So I was gonna. I can't exactly remember how much the TRS version was going for, but ours actually came in under the price. And then we had increased costs when we went to like the Battlefield to get it made, but I think we still came out pretty similar or just under. And then we were because we were able to just take them apart. That you could like later on, you didn't need new hockey stick portions. You only needed the hose portion, so that reduced the cost again.
And probably valuable for their, obviously the durability that you found.
Yeah, the durability, like we'd make like half a dozen to 10 at a time, and they would last for quite a while. So I'm not sure, maybe a few months.
All right, thanks very much, Joel.
Thank you.